Let's go to equal 3,289, the two snitty number of Digitville. You give us an integer array. You say that this number contains all of the numbers from 0 to n minus 1. And there are two numbers exactly appears twice. And all the other numbers appears exactly once. Let's return an integer array, which is these two number, find these two number, right? So if we use on space and on constant times, complexity will be very easy, right? But we can also do this in constant space. So we can use some um, bit uh, mask way, right? So let's do bit mask way. We know there are a number from 0 to n minus 1. So we'll say this n equals nums dot length minus 1, right? So what we do is that we can use a v, right? This v, we can let it XOR from 1 to to n, right? And also, let v XOR nums 0 to nums length minus 1, right? So in this case, we'll see this v, all the other numbers are XOR twice, but the one which appeared twice will be XOR three times, right? So this is a one time, this will be a duplicate, right? So if we have, for example, we have X and Y, which is has duplicates, right? So X and Y, each has been X XOR three times, and Y XOR three times, right? So in this case, V will be equals X or Y, right? We're going to find X and Y, right? So let's write this first. So what we do is that for int I, we can set V, we can write it this way. Int V equals nums n x or nums n plus 1, right? And then for int I equals 0, I smaller than n, I plus, and v x or equal to I XOR nums, right? So let's see, this I is XOR from 0 to n minus 1, and this nums from 0 to n minus 1 and n plus 1, that is to length minus 1, right? So now V is becoming X or Y. So we are finding this V, uh, which is the duplicates XOR, but we still need to find out the X and Y. How can we do that, right? So we have another way is that for this V, right? This V we can for example this V assume this is 1 0 1 0 1 1 0, right? We know if it looks like this, that means X and Y, they have differences in these kind of digits, right? In these digits, we just find any number which has differences, right? And so why we need to find any number which has differences? We can use some kind of number. For example, we can use any number, for example, 0, 1, 0, 0, 0, 0, 0, or, right? Or 0, 0, 1. That means uh, because we have this number, then we can separate those numbers from 0 to n to two categories. One is has a one in these digits, in any of the digits, right? One is uh, uh, doesn't have one in these kind of digits. We can anchor any of this one which has one, right? So we can anchor the lowest one. Um, so we can, of course, we can use a for loop trying to see if n use n1 done equals zero, right? Then return this number. And then, but the thing is that to return, for example, we want to return 0, 0, 0, 0, 1. We can use v uh, and negative v, right? So this is what does this do is that it use invert and a plus one, right? So it will, but this will return the lowest one bit. But we are not necessarily use this way, right? If you don't know use v and minus v, you can use for loop find anyone which has one. That is doable as well, right? Um, so we are going to have v equals v and minus v, right? So um what does this one do is anchor digits. Uh, so that means for example, if we have v which is 1 1 0 1 1 0, right? So it will get the lowest to the one. So we'll return this, right? Well, we just get one of the differences out. So now we'll see for all the number from 0 to n, it can be separated into two groups. One is in this digit, it has one. Another group is in these digits, it doesn't have one. And also we know x and y, right? Because this number v, x and y, they are to become originally, for example, is this, right? So that means they also one has one in these digits, and another doesn't have, right? So two categories has one in digit here, right? So let's say this is D0, this D1, right? D1 and don't and has zero in digit D1, right? And also X and Y, they also one has digits in D1 and one doesn't have digit in D1, right? So we do this is the tricky part. Um, so um, let's assume we want to um, we are going to use the two numbers a and b, and let all of the number doesn't have one to XOR a. So what we do is that for int num in nums. So if num and v, right? V now is becoming the lowest one, right? Just has one to is this number, right? If this one and v equals zero, so it doesn't have, it is zero in digit one, right? So we're going to have, we're going to int a equals zero, b equals zero. So we'll let a XOR this number. Else b XOR equal to this number, right? So we'll see in this case, we'll see x. Let's say x doesn't have zero, right? In this digit, so x must we don't know what x it is, possibly 1 1, but here it should be zero, right? We don't know why what it is for the 101, but this must be 1 at this digit, right? So let's see, x has been XOR A twice. And all the other number which have 1 in this digit has been XOR once. So this A will be all of the number from N which have these digits have 1 don't have 1 at this digit XOR once, but X has been XOR twice, right? So we'll say X XOR twice here. So that means A is all of the number have digits have 1 in this digits has been XORed except X, right? So then what we do is that we also do another for loop for int I equals 0, I smaller than n, I plus plus, right? So if I and v equals 0, right? If it doesn't have these digits, uh, digits doesn't have digit there doesn't have 1 at these digits, then we have a XOR equal to I, right? And else b XOR equal to I. So in this case, we'll see a has been for all of number don't have 1 at these digits has been XOR twice, right? But those duplicates has been XOR 3 times, right? So this is twice and another time. So only the duplicate X being XOR 3 times, so A become X. And also B, only those have 1 at the digit 1, only Y XOR 3 times, so B become Y, right? So in the end, just return new int A, B. So doing like this, it will have ON time complexity in the um in the constant space complexity, right? This will be length minus 2. Let's also write a Python code for this. So what's the n equals the length of nums minus 2, right? So v equals nums n XOR nums n plus 1. Then what we do is for I in range n, then we're going to have v XOR equal to I XOR nums I, right? So then so now let's see v become x or y, right? And then we'll have v equals v and minus v. That is get lowest bit digits, right? So we're going to have a b equals 0, 0. For num in nums, if num and v equals 0, right? So all of the don't have be 0 at those kind of digits, right? So we're going to have a XOR equal to num. Else I have b XOR to num, right? Then we do another time is for I in range n, right? If I and v equals 0, so I a XOR equal to I, else b XOR equal to I, right? So in the end, all of that a and b, a will become x, and b will return y, become y, right? Return a, b. let's look at this will be V XOR if none and length none minus 2 XOR equals V equals minus V and for none equals if none and V equals 0, A and XOR equal to none. As for I in range, what's the problem? XOR nums I. If none and V equals 0, else B nice. This is not the end, right? This should be XOR.